Question 1, core 1 box plot. Let's press pause. Let's get down these two box plots, compare the two distributions, and press play when you're ready on this exam style question. So the box plots show two identical 200-meter races run by identical boys and girls, two categories in year 9, and these are their respective seconds. So for boys, we simply show the box plot with the 5 statistics we just talked about, and the girls with their respective statistics as well. Now the question says compare both the sets of distributions on the time taken by the boys and the girls. So comparing is a technique we need to learn, and this comes up quite a lot, comparing two different sets of data or two box plots. So the first thing we need to know is what statistics do we actually compare. So the first thing we do is compare the median, okay? The median or the average for both of these sets of data. So let's take a green one to show for the median, green color. The median for the boys is 41 seconds and for the girls is 49. Now the lower the number doesn't mean the worse number that is, okay? Now the lower the number sometimes has to be linked to the actual applications. So for example, for this question involving athletes or students running the race, a lower seconds means it's a better result because they've taken quicker to do it. So let's take two categories. We'll take the boys over here and the girls. So the median for the boys was 41 and the girls was 49. So 41 is less than 49. So you need to write something about how 41 seconds is less than 49 in the race, and therefore that's why it's a better result. Okay, so always link it to the application. We won't write it. We'll leave you to do it in a subjective way. I'll just leave a little bit of dashed lines there for you to do that. Number 2, let's talk about the second statistic. It's called the interquartile range. Upper lower quartile, take away the lower quartile. We talked about this meaning the same thing as a box. Okay, so maybe we'll call it orange over here. That's the same thing over here. Let's work at each one of these for each respective sets of the boys and girls, and then we'll compare them. Okay, get some keywords for you. So the boys, upper quartile, 48 take away 31. That would be 17 over here, and for the girls, it would be 57 take away 36, a bit more, 21. So boys is less than the girls. Now, is that better or is it not? I mean, the lower the interquartile range, the more consistent the data is. Okay, so the boys are more consistent, and this is the key word you need to really write in the exam. It's consistent or predictable or lower spread, either one of those words. Yes, consistent, more predictable, or it has less of a spread. That means it's better, okay, because it's more aligned to the actual race. It's like more pupils are actually running the race within these intervals, rather than one being maybe super fit and running the race really fast and one lagging behind and taking, let's say, a long time. All right, so anyway, so this is what you really want in this question over here. Interquartile range, the lowest interquartile range means the more consistent. Write that down as well. That's where you get the marks. Median and interquartile range. Question 2, core 2. So let's try to write this question down on this advanced science formula question. This is all about speed equals distance over time. So the same method we're going to be using from this core 1 question we just had. Let's read through this carefully. Let's apply the same principles on that split table we used, but now it's for speed equals distance over time. Press pause, press play when you're done. So now we'll drive from town A to town C. So this is the whole total effective journey. At an average speed of, let's say, 45 kilometers per hour. It took him 24 minutes, that's the time, for this total journey. Breaking down this journey, let's say he drove from town A to town B in 15 minutes. We'll color code these in the same way as the last question, by the way. And he covered a distance of 12k within town A to town B. So the question is saying find the speed Noah traveled from town B to town C. So we're looking at basically this middle column, if that makes sense, okay? The single column B to C. Anyway, let's get down to creating our split table of 3 by 3. 3 lines here and 3 lines here. All right, and let's try to fill in what we have so far. Now this is the same thing. It's SDT. So SDT. And we'll write the first leg of the journey, the single journey A to B over here. Second leg B to C. And this is the total A to C over here. All right, if you want to, we can put this, you don't have to, but it helps in this introductory understanding of this topic. This plus this equals this. This is the aggregate of both single distances, and this over here is aggregate of both time. This is the average speed, by the way, not the total, the average speed, this one. This is average, total, total. Right, let's now get down to the question. So the first thing, let's fill in what we have. Always fill in what we've got over here. So we have AC 45 kilometers per hour. We have this as 24 minutes. Now 24 over 60, convert this to a decimal. Okay, if you break it down, we get 12 over 30. Break it down 6 over 15, and break it down even further. You could say it could be, what that would be, 2 over 5, which would be 0.4. Okay, write them as decimals. What else do we have? A to B is 15. So A to B, your single column over here, 15 minutes. This is 15 over 60 as well. It's a bit easier to do, 0.25. Okay, look at the decimals, by the way, not the brackets. And 12 kilometers over here. Right, now we want to find out what? We want to find out the speed from B to C. So in effect, the whole point of this is to fill in what we have, kind of like work backwards and get this square over here. Okay, now to do that, let's just work logically and see what squares we could fill up. So the first thing we're looking at is this thing over here, the speed. Is it possible to find out the speed? We'll call this split table, by the way. Well, yes, it is, because, well, look at this. Let's remind ourselves of our triangle. Our triangle is SDT, by the way, SDT. And this is x over 60. Okay, so to find out this bit, let's call it number 1. We'll call it number 1 if you want to over here. This speed will be distance divided by time. So 12 divided by 0.25. Let's multiply the bottom by 100 and the top by 100 to make the decimal into a whole number. 1200 into 25. Non-calculator, do this bus stop method. We won't do it now. 48 kilometers per hour. So that's 48 over here. Does that help us? Let's have a look. Well, we can't simply say 48 plus something is this. It doesn't make sense. So let's fill up. What else can we do over here? We can fill up this one. Let's call it number 2. Okay, so number 2. 0.25. This is easier. Plus something gives us 0.4. Sorry. This is 0.15. So did you see that? We won't even write it down, basically. It's an aggregate, these two. So that's pretty much done over here. What else can we do? We can figure out this one over here. Number 3, let's say. Number 3, we can say basically, so to find out this one, we can say that distance over here is speed times time. So speed will be 45, that's the average speed, times the aggregate or total time, 0.4. That's saying 40% of 45, 10% is 4.5, times by 4, 18. Okay, 18 minutes, that would be over here. We'll write it down. We're nearly there. What else can we find out? This is an aggregate distance, so number 4. This would be 6. 12 plus 6 is 18. It looks quite complicated, but really, once you get one going, it keeps going. It's like a Norton Crosses board, really, isn't it? It just keeps going with this, okay? You can't really predict what's going to happen. You go with the flow on this one. So number 4, I think we're okay with that, aren't we? Okay. Number 5, we're nearly here. Okay, so this one, so speed. So speed, how do we get this? Well, number 5, let's call it number 5 over here. This is the average speed. So average speed will simply be the distance divided by time. Distance is 6 over 0.15. So if you do this, we times this by 100. We times, again, the top by 100 as well. 600 over here. 600 over 15. Do the maths. If you do the long bus stop method for this, 4 and then a 0, 40. Whew, there we go, 40. So the answer is going to be 40 kilometers per hour. That was Noah's speed from town B to town C in 5 steps. Again, it's not rocket science. The trick is to basically just fill in the split table as much as you know, all the information from the question, and then obviously if you understand this is a single column AB, this is a single column BC, and AC is your aggregate, except for this one, which is an average. You're pretty much sorted in terms of you finding the right ones. They all flow into each other. Press pause, write these 3 parts down, press play when you are ready. So here we're identifying a different kind of quadratic over here. More specifically, we're looking for a non-1 coefficient, which is 3 in this case, which gives it the name of advanced quadratic or advanced quad, as we'll call in this video over here. So any quadratic is going to be in this form over here, which we haven't mentioned before, ax squared plus bx plus c. And this will, you'll need this now because of the way we're going to look at the coefficients a and b and integer c over here. So first step is step 1. Now step 1 is to define a quad box. So the quad box is used for basic and advanced quadratics. So you should know this by now. It's two numbers that multiply to get. Now it's two numbers that multiply to get A times C. Okay, so A times C over here. A times C. So A times C would be 3 times minus 4. So 3 times minus 4 is what we need to do over here, which is minus 12. Okay, and we want two numbers that add up to get the middle coefficient, which is going to be B, which actually is going to be over here, plus 4. So your quad box is set up nicely. Let's figure out the first row first. That's the technique. So the first row would be, let's think of this. Think of, two numbers that multiply to get minus 12 and add up to get 4. So we can think of 6 and 2. That will work straight away. Think of them until you get that 4 there. So it'll be obviously 6 and minus 2. 6 and minus 2. Let's insert this as well into here. So we're going to insert this too. So step 1 is to insert these into your original quadratic. So we've got this as such. We've got 3x squared. Let's write this over here. 3x squared plus 6x minus 2x minus 4. Now look how these two numbers have been inserted into the quadratic, because you've got to agree that this is the same as this over here. The plus 4x is the plus 6x minus 2x. So step 2, let's do this. Step 2, we're going to now split and factorize. So split and factorize the whole thing. So we split this up. All right, 3x squared plus 6x minus 2x minus 4. Split this up into such and factorize this. So 3x, we're going to factorize the first part. 3x, x plus 2 over here. And what we'll do, we'll leave x plus 2 over here as well. It's a little strategy. We're working backwards because these two brackets have to always be the same, x plus 2. This will be minus 2 over here. Step 3, we're going to combine this. We're going to look at certain brackets over here. So 3x and the minus 2 will form one bracket. And let's say the x plus 2, which will always be the same, will form the second bracket over here. So your final answer would be 3x minus 2 and x plus 2 over here. See how we've taken the two brackets. This could mean the yellow one over here. And this one was the green one. Okay, so there's 3 steps. I'm more or less guaranteed to give you the answer for that. Take note of that. Write them down into your maths memory card, obviously. Let's do part B over here. So part B, how do we factorize? Well, how do we solve 3x squared plus 4x minus 4 equals 0? So let's get the answer for this and equate this to 0. So we've got 3x minus 2, x plus 2 equals 0. Okay, so because we don't do the whole thing again, we take the answer from part A, because these are the same, obviously, these expressions over here. We equate it to 0. Now what we do is split this in 2, and we make each one equal to 0 separately, so they both look like equations in their own right. So let's solve this. 3x equals 2, and x would equal 2 over 3. X would equal minus 2 over here. Oh, that would be your answer there. So those two are your two solutions of how we would solve a equation. You'd obviously just use part A, make each one equal to 0, and solve them separately as equations. Solve 6x squared minus 7x minus 3 equals 0. Let's do this question over here. Now this is straight away an equation, but we have to go around the long way, and we have to basically do it as such where we use the quad box, steps 1, 2, and 3. We can't get away with that. So let's do this really quickly over here. So we find two numbers that multiply to get the last two numbers. 6 times minus 3. What two numbers multiply to get minus 18 and add up to get the middle number, which is minus 7. So let's think of those. We could think of 3 and 6, 2 and 9. 2 and 9 seems good.
So we'll do a minus 9 and 2. Okay, step 1 done. So step 2, obviously, well, let's insert these into here first of all before we do step 2. Let's insert these into 6x squared minus 9x plus 2x minus 3. Notice how this represents the b coefficient minus 7. So step 2, let's now split this in half. 6x squared minus 9x plus 2x minus 3. Let's half this over here and factorize the first bit. So we have 3x here, 2x minus 3. Let's write 2x minus 3 as a little trick because it'll be the same brackets. And let's work back what number goes over here to make that true. Well, it's just 1 or plus 1, that's right. So now we have the last step. We can combine them over here and we can do it like this. Let's write these steps over here, by the way. Number 1, number 2, number 3. Okay, so we're going to simply create a first bracket, 3x plus 1. We got that by looking at, obviously, the numbers in front of this, 3x plus 1. And the second one is the bracket we see in either one of those, which is 2x minus 3. 2x minus 3, 2x minus 3. So let's write that over here, 2x minus 3. Okay, and we're done. That's how you factorize that one over here. Okay, so let's look now at part C. So part C is another type of quadratic. We call this half a quad over here. So half a quad is half a quad. We've called it that because we only have an x squared and an x. And this is one of the back to basic questions. So let's factorize this as normal. We'll take 4x outside. This will be 2x minus 3. Okay, now if there's an x, these little boxes help us. So there's an x outside. Doesn't matter if it's 4x or if it's x by itself. X equals 0 will be one solution. 2x minus 3. Well, you could do it like this if you wanted to. 2x minus 3 equals 0. 2x equals 3. X equals 3 over 2. So there we have it. X is 3 over 2 or x is 0. You're just about to see that, I think.
Press pause, write these parts down A, B, and C, and press play when you're done. So part A, let's simplify this over here. So obviously we're looking at the crab claw method. Let's write this from actually over here. So 3 times 2, 3 times minus root 5, root 5 times 2, root 5 times minus root 5. Now how you do this is up to you. Some students use the FOIL method. It's totally up to you. We use the crab claw throughout maths memory. So let's have a look at this. So 3 times 2 is going to be 6. 3 times minus root 5 is simply 3 root 5. Root 5 times 2 is going to be plus 2 root 5. And root 5 times minus root 5 is going to be 5. If you simplify these things together, we can do it over here like this. All the number terms, 6 minus 5, that will give us obviously 1. And then if you look at all the third terms over here, we have minus 3 root 5 plus 2 root 5. That's simply like saying minus 3x plus 2x. It's minus 1x, or we'll say minus root 5 in this case. So that's the final answer, 1 minus root 5. Let's move on now to these questions over here. A bit different in nature. It's simplifying different numbers.
Press pause, write this question down, find the area of this triangle, press play when you're ready. So the diagram shows triangle AB and C. AC equals 4.3 and CB equals 7.3. Angle ABC is 34 degrees over here. Find or calculate rather the area of this triangle. You know that basically to use the sine area rule, we have to have a triangle looking in this way over here. Side, angle in the middle has to be known, and a side over here. If you don't have these three features in this order, you can't use the sine area rule. Could we use this? No, because we have a side over here, a side and an angle over here. It doesn't look like this. We can't use it. So how could we best use the numbers and data over here in order to find or possibly create a triangle like this? Let's straight away look at this. We have a full pair and we have a half pair over here. We have two clear signs that we could use. Another idea called the sine rule. Not the sine area, but the sine rule, okay? So a full pair and a half pair. So let's see what we can do with this. So we're going to first of all write this down. So sine 34 over 4.3 equals sine A. This is the angle we want to find out, by the way. Angle x over 7.3. Let's divide this full fraction, the full fraction pair together. We're going to get 0.13 equals sine A over 7.3. Put a 1 there, we'll cross multiply. So therefore, sine A, if we do 0.13 times 7.3, we're going to get an answer of 0.949. We'll simply shift sign this answer. So in fact, we'll do it like this. So A will equal sine minus 1, 0.949. And we will get an answer of 71.6 degrees. So that is basically this over here. This is 71.6 degrees. Now we have two angles in this triangle. We have this one and this one. All three add up to 180, obviously. So let's add these two together and let's take it away from 180. So if we do this, if we do 71.6 plus 34, which is going to be 105.6, and 180 take away 105.6, we're going to get an answer of 74.4. So 74.4 is this angle over here. This is going to be 74.4. So therefore, we could say with certainty that we have SAS. We have a side, angle, side. We have a side over here. We have an angle over here. And we have a side over here. Just like this. Side, angle, side. We can chunk this up into 3 steps. And we go ahead with this. We can say we have half times 4.3 times 7.3. And then the whole thing, the third chunk, times sine 74.4. If we do this on the calculator, we're going to get an answer of, let's work this out. So sine 74.4, we're going to get an answer of 15.1 centimeters squared. So that would be your answer of how you would do this. Look back at this and see how we've created an SAS scenario to fit the purpose of creating, or working out rather, the sine area formula.